Now I'm going to give you a difficult integration by substitution example. So let's say you're trying to integrate this. So to do this, let this be u. So let u equals this thing here. So du equals, well, you differentiate this, that would just be this thing, and then it would be dx. And then now you want to make dx a subject. So divide both sides by e to the power of x. That will then give you this. So now we can put this into the dx, and we can put the u into here. So so this thing here will then become 1 over u, and then this thing here is this thing here. So now we need to work in terms of u, because we're integrating it with respect to u. We don't want this x here, so we need to replace this thing here. So go back to the original substitution and make e to the power of x the subject. So u minus 1 equals e to the power of x. So now we can put this into here. That will then give us this thing here. So now everything is in terms of u. Everything is in terms of u. So now to integrate this, you've got one fraction times another fraction. This is just a trick that we normally use. To integrate one thing times another thing, we're going to break it up as one fraction plus another fraction, and we've got to figure out what the numerator must be and what this numerator must be. So so the trick to integrating the product of the two is to break it up as one fraction plus another fraction, but the hard part is in figuring out a and b. So let's well, our next task is to figure out a and b. Let's merge these two fractions together, and it should give us this thing here, and then later on we can figure out a and b. You see what I mean later. So to add two fractions, you need to get the two denominators to be the same. So times top and bottom by u minus 1, and then u minus 1, and then over here times top and bottom by u times by u. So that will then give us this thing here. So now remember, we're trying to figure out a and b. So so notice that the two denominators are the same. So if you merge these two together, it should give us this. So what that means is it implies that when you get this plus this, it must equal 1. So it implies that this thing plus this thing must equals 1, and our job is to figure out a and b. So let's multiply this out for the time being. Au minus a equals 1. Remember, we're trying to figure out a and b in such a way that this thing must equal 1. So looking at this, hang on, looking at this, the two u's must cancel each other out, because this side must equal 1. So it means that these two must be opposites of each other, meaning, for example, if this is 3, then this must be negative 3. If this is negative 5, then this must be positive 5, because they must cancel each other out. So looking at this, how do you make this to be 1? Well, looking at this, a must be negative 1. And then if a is negative 1, then it means that, well, remember, these are opposites of each other, a and b. So it must mean that b equals positive 1. So basically, do whatever you have to do. Find a and b in such a way that this side equals 1. It turns out that a is negative 1 and b is 1. So what that means is this thing here is negative 1, and this thing here must be positive 1. So that will then take us, hang on, that will then take us to here. That will then take us to, hang on, that will then take us to here. So you trying to integrate this is that, well, these two blocks are exactly the same as these two blocks. Okay, so integrating those two, when you integrate this, this, it becomes negative natural log absolute value of u, and I'm expecting you to know how to integrate this, so you must know how to integrate this by now. And then when you integrate this, it will be absolute value of u minus 1. So integrating this will then give you this plus c. But I'm going to, rather than me doing plus c all the time, I'm just going to leave it right to the end, and then right at the end I'm going to plus c. So let's leave c out for the time being. So now let's switch these two around so that this goes in front and this negative is after. So now when you hang on, so what is u? U here, earlier we said let u, earlier we said let u be this thing here. So u equals 1 plus e to the power of x. So what that means is we can put 1 plus e to the power of x into here and into here. That will then give us this thing here. And whenever you have one thing take away another thing, that's the same as you getting one thing dividing by another thing. And remember, log of a minus log of b, that's the same as log of a divided by log of b. Well, anyway, these two, the one here and the one here, they cancel each other out, giving you e. So that will then take you to here. And from here, hang on, from here, remember e to the power of x looks like this. E to the power of x looks like this. E to the power of x will never be in the negative realm. It's always positive. E to the power of x is always positive. So we don't need the absolute now. So we can just discard the absolute. And then this thing here, e to the power of x will never be negative. And then when you add 1, the combination of the two will never be negative. So you can omit the two absolute signs. So that will then give you this. So in short, when you integrate this, it will give you this thing here. Okay, so now let's double check. If you were to differentiate this, it will then give you this thing here. So let's double check. So let's check. So we're going to try and differentiate this, and it should give us this thing here. Okay, so let's differentiate just to double check. So just to double check, when you differentiate this bubble, it will be 1 over the bubble, and then you times the derivative of the bubble itself. But within the bubble here, you've got to use the quotient rule. So you square the denominator. So you square the denominator. Hang on. Remember the quotient rule. V u prime minus v prime u. So v squared will be this thing here, and then the v stays the same. And then when you differentiate the numerator, it will be its exact same self. And then you got minus minus. Differentiate the v. So when you differentiate the v, it's actually the 1 goes, and then e to the power of x, and then you leave the u alone. You leave the u alone, which is this thing here. So when you differentiate it, it gives you this thing here. Now tidy this up. This block here becomes this, and then here you got one block. Take away another block. Notice that e to the power of x is in common. So factor out e to the power of x. So this times this will then give you this thing here. This times this will then give you this thing here. So in short, factor out the e to the power of x. That will then give you this. So now you've got one fraction times another fraction. This block here will get cancelled out with this one here. Well, don't forget you've got 2 blocks here. Let me get rid of this. You've got 2 blocks. So this block here will get cancelled out with this block. So that will then leave you with this thing here, which is this thing here, over this block here. So now these 2 blocks will cancel each other out, giving you 1 over 1 plus e to the power of x, which was what we were trying to integrate all along. So in short, to integrate this, the answer is this thing here. Okay.